Nano green printing technology. Newspaper and book samples can be printed without the need for photosensitive washing or the generation of wastewater or waste liquid. The circuit boards of computers and mobile phones can be easily printed without etching. These seemingly magical technologies have become a reality with the efforts of researchers. At the industrialization base of the Institute of Chemistry, Chinese Academy of Sciences located in Huairou, Beijing, we experienced the magical charm of nano green printing technology on site. I saw several seemingly inconspicuous plate-making machines in the production workshop, and the staff were putting an aluminum plate into one of them. In less than 3 minutes, a printing plate came out from the end of the machine. There is no pungent chemical smell, no sewage pipes, and even no loud noise. The entire newspaper and magazine plate-making process is easily completed in less than 10 square meters of space. High resolution, energy-saving, and environmentally friendly, and low-cost, nano-green printing technology is revolutionizing the traditional printing industry and printed circuit board industry with its significant advantages, and will also bring many changes to our work and life. 5 years ago, Song Yanlin, a researcher of the Institute of Chemistry of the Chinese Academy of Sciences, led his team to start a pilot study of green plate-making technology after deeply realizing the serious environmental pollution problem in the traditional printing industry chain. The core concept of nano-green printing manufacturing is to combine nanomaterials with printing technology to achieve the green, functional, three-dimensional, and device-oriented printing industry. The principle of traditional printing plate making is photosensitive imaging and chemical development, while green printing plate making technology uses nanomaterials to make special plates and ink, and directly prints to present hydrophilic blank areas and ink-friendly image and text areas on the surface of the printing plate, which can be directly printed. Simply put, the principle of green plate making with nanomaterials is to print a hydrophilic image and text area on a hydrophilic plate material, forming a difference between the image and text area and the blank area through the difference between oil and water. The plate material itself is hydrophilic, which makes it not contaminated with oily ink. On the other hand, the image and text area on the printed material is printed with hydrophilic nanomaterials. In this way, when printing on the plate, the area with hydrophilic nanomaterials is printed with images and text, while the area without printing is still blank. Song Yanlin further explained. Laser phototypesetting technology requires 2 exposures for development, which is cumbersome and involves the use of chemicals such as developing and fixing solutions, resulting in significant pollution. Even the most advanced computer direct plate making technology, CTP, currently requires photosensitive pre-coating and chemical treatment processes. The solvents used in printing ink are mainly aromatic hydrocarbons, esters, ketones, ethers, etc. After drying, about 70 to 80% of the solvents directly evaporate into the air. The harmful components such as heavy metals in ink also pose serious health and food safety risks. The new nano-green printing technology does not require any darkroom or exposure process, nor does it generate wastewater or waste liquid, and its cost is more than 1/3 cheaper than traditional laser typesetting. Replacing the original process of electrolytic oxidation with nanocoating, printing with nanomaterials instead of exposure imaging, and using water-based ink instead of oil-based ink to solve over 80% of pollution in the printing industry chain from the source. The traditional printing industry has generated a large amount of photosensitive waste liquid, harmful solvents, and substrate electrolytic waste liquid. Similarly, the traditional printed circuit board industry also causes significant environmental pollution, with production waste containing a large amount of heavy metal ions, seriously polluting the environment. In response to the 3 major pollutants generated during the production and use of plate making, plate base, and ink in the printing industry chain, nano-green printing technology replaces the original electrolytic oxidation process with nano coatings, replaces exposure imaging with nano-material printing preparation, and replaces oil-based ink with water-based ink. This green printing technology system can solve over 80% of pollution in the printing industry chain. After the comprehensive promotion of nano-green printing manufacturing technology, the country can reduce emissions of tens of thousands of tons of organic solvents, millions of tons of waste liquid and wastewater every year, saving hundreds of tons of silver and tens of thousands of tons of copper and other metals. Different nanostructures have different properties, such as hydrophilicity and oleophility. We have found the rules for controlling nanostructures and surface properties. Song Yanlin said that by making the substrate material into a superhydrophilic structure and printing superhydrophilic nano transfer materials on it, the printing clarity of the resulting printing plate will also be greatly improved. Researchers have also overcome the problem of high-precision patterns formed by printing nanoparticles by printing the smallest ink dots currently containing only 1 nanoparticle, which are then connected to form the thinnest lines, forming a flat surface. Due to the advantages of low cost and flexible preparation of flexible circuits, nanomaterial green printed circuit technology can improve the production technology level of the traditional printed circuit board industry. It is particularly important that the current circuit board manufacturing uses etching technology, and about 90% of the copper in a single copper-clad board will corrode, causing serious environmental pollution. We can avoid environmental pollution and material waste by using metal nanoparticles and printing to do this, said Song Yenlin. In addition to printing books, newspapers, and magazines, subway tickets with higher sensitivity can also be printed. In the future, mobile phones, computers, and TV screens may be printed and rolled up to take away. In addition to printing books, newspapers, and magazines, nanoprinting can also produce electronic ticket cards with higher sensitivity. Song Yenlin introduced, the subway tickets we use contain chips and circuits. Currently, the technology for printing subway ticket circuits has passed comprehensive assessments, fundamentally eliminating pollution while greatly reducing costs. It is reported that new technology printed tickets not only have the advantage of high sensitivity, but also have more environmental benefits. Existing tickets are difficult to recycle, and tickets manufactured using nano-green printing technology can be repurposed. Pulp and metal are separated by gravity, and the vast majority of materials can be recycled and reused. We are still improving this technology, and various documents such as ID cards can also be printed in the future, said Song Yenlin. In Song Yenlin's eyes, the green printing and manufacturing technology of nanomaterials has broad application prospects, which is a revolution in manufacturing technology for multiple traditional industries and will also give rise to many strategic emerging industries. After this technology matures, it can be applied in many industries such as electronic paper, electronic clothing, the Internet of Things, flexible displays, electronic decoration, solar cells, lighting wires, sensors, etc. At present, nano-green printing technology has achieved pattern printing on various materials such as plastics, textile fabrics, glass, ceramics, etc., which can solve the problems of high pollution and high energy consumption in traditional production processes. Perhaps in the future, mobile phones, computers, and TV screens can all be printed out and rolled up to take away, said Song Yenlin. Our technology, which started with printing and changed China's industrial pollution situation, can extend to a wide range of fields. This will be a new technological revolution.